Okay, so today we're starting the multiplying integers and rational numbers. Remember, guys, rational numbers have what? What's the difference? Rational number has kind of those, there we go, the decimal values and the fractions. So we're going to explore all of that today, all right, in this set of notes. All right, so we need to know our rules. Okay, how do we know what the sign of our answer is going to be? All right. It's what we call the even-odd rule, that you count how many negatives are in the expression. Notice I didn't say how many numbers. I said how many negatives are in the expression. If there is an even number of negatives, guys, do we know what even number means? Yeah. 2, 4, 6, 8. Okay? And then it's a positive answer if there's an even. If there are an odd number of negatives, I have a negative answer. So my odd numbers, 1, 3, 5, 7. Okay? So when I look at the expression, I want to see how many negatives there are. That tells me the sign of my answer. And then I just do the multiplication. Okay? All right, did you guys get those filled in? I think there's a couple blanks on that. All right, so in example 1, I'm going to multiply the integers. Number 1, is this going to be according to my rule? Okay, how many negatives do I have in the expression? How many negatives do I have? Hadley? 2. So my answer is going to be what, class? Positive or negative? Positive, because 2 is an even number. All right, can I let you in on a hint? Most of the time, it's going to be either 1 negative or 2 negatives. 1 is odd, negative answer. 2 is even, it's a positive answer, okay? But sometimes you're going to have 3 and 4 and 5 terms, so that's where the even odd can help us. All right, so we know our answer is positive. Positive what? 30. Positive 30, because 5 times 6 is 30. So once we decide on the sign of our answer, we just do the multiplication. Okay? Number 2, is my answer going to be positive or negative? Negative. And what's 3 times 4? 12. So these are not overly difficult numbers to multiply. Okay. What about number 3? Negative 25 times 0. Anything times 0 is? 0. But let me ask you this. Technically, it's negative 0, but there's no such thing, right? So we don't have to say negative 0. We just say 0. 0 is not positive or negative. All right, so even though according to my signs it was supposed to be negative because it was 0, I just say 0. All right, go ahead and do numbers 4, 5, and 6. When you're done, check it on your neighbor. Okay, number 4, class, what is it? Negative. All right, that was weak. Everybody together. Number 5. Just 25. Number 6. 9. Okay, 9. All right, now this is the one where I'll see some people get the sign wrong because they say, oh, it has the same sign, so I multiply and keep. Okay, but remember, you're like blending 2 sets of rules there. We multiply, but then it's 2 negatives, so it's a positive answer. All right, and that's just going to take some practice. All right, so that's integers. Okay, now let's do decimals and fractions. All right, the good news is I multiply decimals and fractions just like I always have. The only difference with the negatives is it's going to determine the sign of my answer. All right, so before I even start, all right, because I promise you guys, and actually I forgot in the last class I had to go back, write it in your answer first. So is your answer positive or negative? Oh, that was weak. How many negatives do I have here? 1. So that's a negative answer because 1 is odd. Now I want you to come down and do the multiplication. Remember, with multiplying decimals, we line up the digits. We line up the digits when we multiply decimals. Okay, 5 times 6 is 30. 2 times 6 is 12, plus 3 is 15. 0 placeholder. 15. All right, and now I'm ready to add. And I get 900 as my answer, right? No, what did I forget? What did I forget? You gotta, how do I know how many decimals? Yeah, how many decimals are in the numbers multiplied? 2, so I put 2 decimals in my answer. Okay, so my answer is -9. Remember, come back up there and don't forget the negative. -9. Okay, fractions. Multiplying fractions. Do I need an LCD? When I multiply, do I need an LCD? No, no LCD when I'm multiplying. Again, it's a common mistake. We just get in the habit. We're like, oh, fractions, I need an LCD. But you don't when you multiply and divide. All right, guys, remember that? Okay, so the parentheses tell me multiplication because there's no other sign between the fraction and the parentheses. Okay, so, what do I have here? Mixed number, but we said across the board with all the operations, we changed the mixed numbers to what? Improper fractions. It helps us avoid a lot of mistakes if we just do that across the board. So -1/3 times, what's 2 3/4? 11/4. Yep, and don't forget that -11/4. All right. Now, when I'm multiplying fractions, I want to look for opportunities to cross-reduce. Okay? Because you have no calculator, it can be helpful. Can I cross-reduce anything? No. No, I can't. Okay? So I'm ready to multiply. All right? Now, this is important. This negative in front of 1/3 has to be either connected to the top or the bottom. Okay? It's only one negative. It doesn't go with both numbers. Okay? So what I would tell you to do is connect the negative with the numerators. Okay? Connect the negative with the numerators. Unless it's top and bottom, then that's a different story. So -1 times -11 is what? 2 negatives. It's going to be 11. Positive 11 over 12. All right? And if I go back to the beginning, I can see right off the bat, I was multiplying 2 negatives. That's even, so my answer should be positive, and that's what I found at the end also. Okay? So multiplying fractions, I multiply them just like any other normal fraction, but then I have to pay attention to the signs to know the sign of my answer. All right? Are you with me on this? Are you following along? Okay? Any questions? Any questions? We'll take a little time out for questions. Anything? All right. Yes. So evaluating expressions using the order of operations. All right. This first column in particular is important. All right. Let's look at the first column to start. What is the only difference you see here between the two, Alexa? The parentheses. Right? You see that? So the parentheses are actually very significant when it comes to evaluating exponents when there's a negative base. Okay, we all know what the base is, that big number at the bottom. Okay, so when the base, in this case -2, is in parentheses, it means that the base is repeating by however many the exponent tells me. So the exponent is a 2, so that means -2 times -2. When it's in parentheses, the negative's connected to the base, and the negative repeats in the multiplication. That's significant because what's -2 times -2?
4.
Positive 4. Okay? So look what happens when there are no parentheses. When there are no parentheses, basically what's happening is I'm evaluating the exponent. Whatever it is, 2 squared, 4 squared, 10 squared, and then my answer is automatically negative. Okay? So your book writes it this way to kind of reinforce what's happening here. All right, the negative's out here, and then I do the operation. Again, 2 squared is 2 times 2, which is, and my answer is negative. Okay? Automatically. All right, so you might say, well, that's kind of weird to me. That doesn't make a lot of sense. That's okay. We're going to keep looking at this concept, but it's very important. If you see no parentheses, just know I'm doing the exponent and my answer is negative every single time. Okay, no matter what the exponent is. All right, if it's in parentheses, then the negative repeats. Any questions on that? All right, I feel like if I keep saying it, it'll just get to be more confusing. Okay, so I'm just going to kind of stop there, and we'll look at it again later on. All right, let's look at the second column now. This one's important because you don't have calculators. If you had a calculator, okay, who cares? 2 times 17 times 5, boom, done. But when you don't have a calculator, you're looking for easier ways to multiply. All right? When it's multiplication across the entire expression, do you guys agree? I'm multiplying -2 times 17 times -5. It's all multiplication. My rule says this is commutative property. When it's all multiplication, I can multiply these in any order I want. All right? So I see an easier order to do this mental math. Yes, Maddie?
2 times 5 is 10, and then add this over to 7.
Yes. What's 2 times 5? 10. And when I multiply any number, 17 times 10, what do I do to it? Add a 0 at the end. That was easy enough. So all of a sudden now, kind of a difficult problem, wasn't so difficult after all. Now I just have to decide, is my answer positive or negative?
Positive.
Positive. Wait a second, I have 3 numbers there. I thought 3 is odd. But there's only 2 negatives. So it's not how many numbers, it's how many negatives. All right? Hang in there with me, guys. We're almost sort of done. Okay? How are y'all doing? Doing okay? I know it's kind of an information-packed lesson, but it seems like you guys are doing okay. All right, now here on this last one, we see something kind of come back up that hasn't been in this lesson so far. Addition. Whew, so we got to switch gears again, because now I need my addition rules for integers. What's -3 plus 4? 1. Okay, so I go back to my addition rules, subtract and take, 1. And now -6 times +1 is what? -6. All right, so you are definitely going to see that. Those addition rules tied in with your multiplication rules. Okay? Ooh, what's your favorite word about this title for example 4? Shortcuts, right? We love shortcuts because shortcuts mean that I get to my answer in an easier way. All right, I asked the last class, so I assume the answer might be no, but did you guys learn what reciprocal means last year? An R, reciprocal? Okay, so reciprocal, I'm going to write on this so it's on the video, but don't write this on your paper, okay? Let's take the fraction 2/3. The reciprocal is the flip, okay? So we just flip the fraction. If we flip this fraction, what would it be? 3/2. And if I multiply a number by its reciprocal, my rule says that everything cross-cancels down to 1, which is really nice, right? That makes it a little easier. So I'm looking for a reciprocal. Anytime I am solving an expression like this that quite honestly looks a little obnoxious, right? You're like, Miss Kendra, why in the world, right? Like this is a little more complicated. You need to look for reciprocals, because it can turn a pretty difficult problem into a very easy problem fast. All right, so let's start off. And remember, commutative property says I can rearrange these. It's all multiplication. Say, well, there's parentheses. It doesn't matter. Every term is being multiplied. So it's all open game to switch around. Does that make sense? Commutative property says all multiplication, I can switch my numbers around without changing my answer. So here's my first one, -1/7. Samuel, do you see a number that I would want to pair up with -1/7?
7.
Yeah, -7. Can I write that as a fraction?
Yes.
How can I write a whole number as a fraction? -7/1. Okay, we know what's going to happen, but don't do it yet. Let's write the rest of it. Times 4/5. Oops, I don't know why I wrote a 2. Okay, times 4/5 times -1/2. All right, now we can cross reduce, right? 1 and the -7, and when I multiply, but remember that doesn't cross down to 0. This is important. It reduces down to 1. Is it +1 or -1? It's positive because there are two negatives. That's significant because if one of them was negative, but the other one positive, this would have been a -1, and that would be significant. Okay, but two negatives, so it's a +1 that it reduces to. Now, I'm going to multiply these fractions. Anybody see what they might do first when they're multiplying these fractions? Lydia? Okay, what is it? Cross? Yeah, cross reduce it, right? The 4 and the 2, right? By a factor of 2. So now this becomes a 2 and this becomes a 1. What is, be careful, what's 2 times -1? -2. And what's 1 times 5? 5. All right. Now, 1 times any number is just that number, but just to be clear, we can multiply 1 times -2, and again, it's just going to be the same answer, -2 over 5. All right? So instead of going back to the original and say, okay, -1 times 4 is -4 over 35, and then I keep multiplying it, I literally rearranged them. I cross-reduced the 2 and the 4, and I multiplied and got my answer. It was a lot easier than what it would have been. Do you see that? I mean, look back to the original. If you start trying to do that in your head, that would have been more complicated, right? It would have been. Okay? So number properties can give us those shortcuts. Okay, 2 more problems, and we're done. Yeah, they have words in them. We call them word problems. I guess technically I don't like that name because we're all scared of word problems, right? Me included. Okay, all right. But this is just kind of like a real life application. So let's read it together. It says a school record. Any track people in here? Anybody run track or any part of track? Okay, cool. For the 40-meter dash is 15.24 seconds. Predict, you're going to predict, the school record after 15 years when the record decreases by 0.06 seconds per year. All right, so there's one way you could do it. You could take 15.24 minus 0.06 minus 0.06 15 times. Does that sound like fun? No. No. So, given the topic of our lesson today, anybody have any ideas what I could do? Yes.
15.24 times 0.06.
Not the original record, but if I know it's decreasing by 0.06 every single year, in how many years? 15 years, I could, what could I do? Multiply it. Multiply it. 15 times 0.06 would give me the total number of seconds that it's decreasing by instead of adding it over and over and over again. Okay? If the same amount is happening. So 15 times 0.06. All right, would give me 90, and then there's 2 decimal places. All right, so this is my answer, right? 0.9. 0.9 is my answer, right?
No.
Is that what it was asking?
No.
Okay, so I know that the record has decreased by 0.9 seconds. So how do I figure out what the new record is? Samuel?
0.9 minus 15.24.
Yeah, the opposite, but yes, I would subtract it from 15.24. Okay, so old record minus the amount that it's decreased would give me the new record. All right, so if you see a value, all right, maybe this would be helpful. If you see a value that's repeating and it tells you how many times it repeats, that it's decreasing by 0.06 for 15 years, you can multiply that. Okay? All right? So again, more practice would be helpful, and that's what we're going to do. All right, so when we subtract it out, we have to borrow That becomes a 12. All right, so the new record is 14.34, and make sure you always label on a word problem. Seconds. Okay. All right, last question. I love this question. Some of you guys might not agree, but that's okay because it's going to challenge you. All right, I'm going to give you 2 minutes, actually, until the clock strikes 1 o'clock, so 2 minutes and a few seconds. Okay, I'm going to read this problem to you. If you get it right before the time runs out, I will give you a piece of candy. Okay? All right, you solve a number puzzle on your phone. You start with 250 points. You finish the puzzle in 8 minutes and 45 seconds and make 3 mistakes. Each mistake is minus 50 points, and each second under 10 minutes gives you 1 point bonus. What is your final score? All right, I'll be walking around. Raise your hand when you have the answer. So you start off with 250 points. And how many points did you lose because of your mistakes?
150.
150 points. Okay? Now, here's what tripped you up, all right? You finished in 8 minutes and 45 seconds, which is how much time under 10 minutes, Samuel?
75 seconds.
75 seconds. So a lot of you probably said 115 seconds because it was 1 minute and 15 seconds. But remember, there are 60 seconds in a minute. So plus another 15 seconds, I would add 75 more points to make 175 points. All right, so a real common answer I got was like 625. All right, so yeah, good job, guys. You know, you can kind of see the integers in here, and that's kind of the tie-in. But obviously, if you did your multiplication parts right of the lesson, that's a little more important. Okay, because of time, and I hate to do this, I really do and fully intend on doing the Think, Pair, Share together. We did a lot of collaborative learning just in the examples, but I do want to go through some of these true-false questions just together. All right, would this be true or false? The product of 3 positive integers is positive. Is that true or false, guys? 3 positive numbers. Yeah, it's going to be positive. That's true. Okay, what about the product of 3 negative integers? Is that going to be positive?
False.
That's false because it was 3 and 3 is odd. Okay, what about your friend down here? Did they do this problem correctly?
No.
All right, I'm hearing no. Why? It's 2 negatives. That's a positive answer. 2 negatives is a positive answer. Okay, and then of course, you know, we have the problems over here, but they're very similar to the ones we've already worked. All right, so that's everything you need to know for multiplying.